In this section, we're going to talk about graphics, and what I want to show you is how you can represent more than two variables on a scatter plot, even though a scatter plot only has an x-axis and a y-axis. So I'm going to start by showing you just a simple plot of 3 data points. Here it is, right? And one thing I've done here is I have changed the point size so that it's twice the default size. So CEX stands for character expansion. Here I've made it equal to 2. These points are just twice the size of the usual points. So that's what I do if I want all the points to be a different size. But what I'm going to show you next is how I can make each point a different size. So note that there are 3 points, and therefore if I give a vector of length 3 to the CEX argument, then what I get is the first point is of size 6, the second point is of size 2, and the third point is of size 3. This is the idea that we're going to use to represent multiple variables in addition to just the x and y axis. So let's use the iris dataset as an example. Here what I've done is I've set the x-axis equal to sepal length, the y-axis equal to sepal width, and then I've set the size of the points equal to petal length. So these are the flowers that have big petal lengths, and these are the flowers that have small petal lengths. And now look, I'm representing 3 variables in one graphic, which can be really helpful to be able to do. One note, just so you can use this in other data sets, the petal lengths in the iris data set happen to be numbers equal to things like 1.2 and 2.7 and things like that that are reasonable character expansion sizes. But very often you have to do something like take the variable that you're trying to use for point size and maybe divide it by 100 or something, or 1,000. Because you don't want point sizes that are equal to 1,000 times the default. You can do this for color as well. So in the iris dataset, for example, species is a categorical variable. So you can imagine that we might want to have a different color associated with each category. There is a simple way to do this where, I'll just show you really quick actually. There's a simple way to do this where you let R choose the colors. So if I did, first of all, COL equals red, then all the points turn red. Okay, that can be helpful. If I do COL equals and then just give it the categorical variable from the data set, then R will choose a color corresponding to each of the values of that variable, which is helpful. However, sometimes I'd like to be able to choose the colors myself. Maybe I don't want them to be black and red and green. So here's how you do that. I'm going to use the REP command. So the first thing I'm going to do is make a new vector called col.iris, which is coming from repeating the word red 150 times. In other words, the rep command will repeat this thing this many times, and the number of rows in the iris data set is 150. So if I run this and then look at it, col.iris is equal to the word red repeated 150 times. But that's not what I want. What I want to do is have this vector be equal to red or blue or green depending on what species is in each row of the data set. So if you remember that iris $ species looks like this, in other words, the first 50 rows in the data set are Setosa, next 50 are versicolor, next 50 are virginica, then if I look at this logical statement, iris $ species equals versicolor, what I get is a false whenever it's not versicolor and a true whenever it is versicolor. So this line of code says, okay, take that col.iris vector that I just made, where the species is equal to versicolor, in other words, where I have a true here and set it equal to blue, right? And if I do that, then my vector, which was originally all reds, now has blues in the places where the species variable is equal to versicolor. And I can use the same logic to turn that vector green when the species is virginica, and then now I have this vector which is of length 150, but has the word red or the word green or the word blue corresponding to what the species are. And now if I put that into my plot command as my col argument, now the species are colored according, now the plants are colored according to species based on the colors that I chose. And if you want, you can add legend. I'm not going to show you how to do that today. But this is a nice way to choose what color you want. And if you look at this, I am representing 3 different variables very clearly here, right? Sepal width, sepal length, and color represents another dimension of the data. So, okay, so we talked about sepal width and sepal length on the actual axes. We've talked about color for species. We talked about changing the point size based on the petal length. There's one more variable in the iris data set, and that's petal width. So what else could you do here? Well, in addition to changing the size of the points or the color, you could also change the symbol used for each point. There are a whole bunch of different symbols that are possible in R. To give you a sense of that, I'll plot this for a second. If I do, it's called PCH for point character, and just set that equal to the numbers from 1 to 20, just to show you, like here are a bunch of different symbols that you could choose in R. So when PCH is equal to 1, you get circles. That's the default. But 2, you get triangles. 3, you get plus signs, etc. This is one of my favorites, this kind of filled in circle, right? I often use 16, kind of a bigger filled in circle instead of the empty circle. So this is something that's helpful to know in general, right? That if I wanted to, I could even take this code here and just say like PCH equals 14, right? And now all my points have some symbol other than just the circle. But what I want to do here is I want to change the point style to represent this other variable in some way. And so arbitrarily, I'm going to decide that when the petal width is greater than 1, I want to have a triangle. And when petal width is less than or equal to 1, I'm going to have just my usual circle. So I'm going to do this in the same way that I did for color. PCH.iris is going to start out as repeating 1 150 times. Okay. But I'm going to take that vector where the petal width is greater than 1, right? So sometimes that's true, sometimes that's false. And where petal width is greater than 1, PCH.iris is going to be set equal to 2. You can see this vector. There it is, 1 or 2. So now here's my final plot that I'm going to show you. Sepal length on the x-axis, sepal width on the y-axis. The size of the point will be corresponding to the length, the color of the point will correspond to the species, and the type of point symbol will correspond to the petal width. And there we go. Now, I'm not arguing that this is the most beautiful plot in the world, that this is the type of plot you should always make. Rather, I'm showing you several options for how you might represent a variable other than on the x or y axis. And if you think carefully and experiment a little bit with any particular data set, changing the color or the point type or the point size or a combination of those can be a really helpful way to represent a data set that contains more than 2 variables.